to. There we go. So here, this is a table that's quite important. I'm not looking for like exact answers here, it's more looking at trends. Like when we look at shape, I just want you to know that solids hold their shape the most, gases and plasmas the least. So that's what we're putting here. We're talking about containers. What we mean by that is that a solid has a fixed shape. If you put like a ball inside of a cup, it's not going to take the shape of a cup. A liquid would take the shape. If you pour water in from a bowl to a cup, it's going to end up being in a different shape. Gas is just going to fill the entire container and bounce off the walls and move in every direction and do all that wild stuff. And plasma will behave like gas as well. So we're just saying here how solids have the most form and gases have the least. Density, similarly, we have the most density in solids, the least in gas. For all these, just look back at the lessons and you'll see lots of good picture representations of how solids so packed in its molecules, and gases are just like going around everywhere and there's like space between them. Most of these, just by looking at the photos, you should be able to get an idea of. Bond strength, similar. The strongest are going to be in solids because they're like all bonded together. And compressibility, solids are the least because their molecules have the least space between them. Kinetic energy, solids is the lowest, gases are the most because they move the most. Diffusion, gases are the most because there's the most space between. All the things in this sheet, you can just like look at the PDF posted of this, but they're all just trends that make sense if you think about how solids have all the molecules closest together, and gases have so much space between their molecules and they're very far apart. So obviously it's harder to push things together when they're already together, and when they're far apart, it's a lot easier to push them together because there's more space there. That's all these are saying. Volume, solids are fixed, and liquids are fixed. This one's interesting because imagine you take 100 milliliters of water. No matter what bottle you have that in, it's going to be 100 milliliters, but it could look like more or less depending on how like wide the bottle or the cup is or whatever, but it still has a fixed volume. Gases, on the other hand, they're just going to have the same volume as the container they're in because they're going to go in every direction. They're not going to like stop at some upper level or something. But we're going to learn another term soon called pressure that we talk about here. You've heard of pressure a bit already. Then molecular arrangement. Solids are like crystalline, very arranged. Liquids have an attraction to each other, but they're fairly weak in their arrangement. And then gases are just randomly arranged. So explain the difference in compressibility. I was already speaking to this, but gas has the most space between molecules, so it is the easiest to compress. Solids have the least space between molecules, so they are the hardest to compress. Again, I recommend you go back to the lesson videos from the last couple days just to get this ironed out and get more visual examples, because this is an important understanding to have as we're moving into the assignment tomorrow and also into gases and state changes. State changes next week, then gases to follow. Cool. So here, I'm going to try to block these off okay. This one you might be better off looking at the sheet too, because it's kind of just a bunch of definitions. Maybe I'll just talk about these ones and block this off for now. But intermolecular force, that's the force between two molecules of the same substance. So if they're like attracted to each other and not attracted, so we'd say solids have the most, gases have the least. There's a photograph in your last lesson that shows this pretty well. Kinetic energy is the energy created from movement, and it's measured as a temperature. And diffusion is the movement of substances from an area of high concentration to low concentration. All of these definitions are in your booklet and the lessons, so you should be taking them from there and just noting them here as review. But on an assignment or a quiz situation, these would be definitions that you would be that you should be able to explain in your own words and use. So order the states of matter from lowest to highest. So compressibility, we were doing this on the last page. Solids are the least, gases are the most. Density, gases have the least density and solids have the most. Kinetic energy, gases have the most and solids have the least. These are all, again, just based on the amount of space between molecules. So I recommend going back to the lesson videos and just really internalizing those photos of gas being all spread out and bouncing everywhere and solids being all tightly arranged. Because once you understand that, all of these can sort of be reasoned out of it. You don't really have to memorize. You can just sort of think about it in terms of space, right? So just to restate that, compressibility, solids don't have any space between their molecules relatively, so they're going to be very hard to compress, whereas gas is mostly space, so they're very easy to compress. Density, solid, again, has a lot of molecules in a small area, so it has a higher density than gas, which has the same amount of molecules spread over a much larger area. So explain why liquids and gases take the shape of their container, but solids do not. So here, just gonna get this to be a bit wider. Solids have a fixed volume due to their high intermolecular forces. That means that they're very attracted to each other and they don't really get pulled apart or spread out to their container. They'd rather be all tight and right beside each other, so that's how they stay. And then again, this compression thing, we're hitting it home again. Solids do not have the space between molecules to be as compressed, gases do. Then similarly, explain why you can walk through air, but you cannot walk through a wall. This one's interesting because we all know gases are so compressible because we just walk through them all the time. If you go to pick up your pencil right now, you're moving through gas, the air around us. So there is space between gas molecules to compress into when pushed, and that happens very, very easily. Give 2 reasons why peanut butter is not considered a true solid. This is kind of a silly question, but you can just get creative on it. I just put it takes the shape of its container. It can be spread. It's kind of flowy. You can compress it. There's so many things you could say here, but this is just kind of food for thought. No pun intended. So what would diffuse faster? Explain why. This is a bit of a trickier question. You have to think on this one quite a bit. But I'll just go ahead and tell you that N2 would because it has a lower molar mass. And the lower the molar mass, the faster diffusion is because the molecules can move faster. The lower the mass, the quicker a molecule can diffuse around. Just think of it like buzzing around all like speedy. Explain why there's a difference in diffusion between solids, liquids, and gases. That is because stronger intermolecular forces holding molecules together decrease diffusion. So solids are harder to diffuse because they're held together much stronger. How would adding heat affect the kinetic energy? Heat increases the speed of particle movement and thus increases kinetic energy. So all that's really saying is the hotter something is, what it literally means is the particles are moving faster. And the faster particles are moving, the higher kinetic energy is, because you can think of kinetic energy as like mass, function of mass and velocity. So if mass goes up or velocity goes up, kinetic energy increases. How would adding heat affect the rate of diffusion? At higher temperatures, molecules move faster and further apart, which increases the rate of diffusion. So higher temperatures make diffusion more easy. Are we missing a page there? No, okay. That was just the notes page. We don't need that right now. I just have a thing covering it. Did I? Okay, this is just like your page of notes. Don't worry about that. Then here's some more questions. I'm just going to talk to these quickly for the sake of time. But explain why a balloon filled with gas can be twisted into balloon animals. Why would it not work with water? Gas allows a lot of room for twisting due to its high compressibility and the movement of the molecules. If you just pinch off gas in the middle, all the molecules could run to each side and they can easily just adjust to being more compressed. Water, on the other hand, is less compressible and does not quickly fill its new container like gas does. It would have to kind of flow and be all droopy and have a lot of like weight, and it just wouldn't work nearly as well. You can imagine twisting a water balloon. It's going to push back more and it's going to feel a lot less evenly filled. Why would increasing the temperature of a gas change its kinetic energy? Why would that increase pressure? Why would that be dangerous to aerosol cans? So heat increases the speed of molecular movement, and faster moving molecules increase kinetic energy. And then if you think about pressure, pressure is something we're going to look at more and more as we move forward. But pressure is just how many times a particle is going to hit the edge of the container. If you think my mouse is a gas particle and this is the container, it's going to keep hitting. And the faster it's moving, the more it's going to hit. You see that? So faster moving particles mean more collisions, which means more pressure. And if pressure gets too high, like we keep hitting the sides of this container over and over and over and over again, that went crazy, but we keep hitting it over and over and over again, like keep hitting the edge of the container, it could explode. So that's why a hot can that's already under high pressure, like a can of hairspray or something, could blow up if it's left in the car in the summertime. Last, predict what would happen if enough energy was removed from a sample of gas to slow down the molecules of a gas and bring them closer together. This is a preview of next week when we're going to be looking at phase changes. But as you can maybe imagine, if you slow things down enough and cool them down enough, gas will turn into liquid, liquid turns into solid, like when you put water into the freezer and it turns into ice. Um, but that process of gas to liquid is called condensation, and we will look at it next week. With that in mind, if you are rock solid in all this stuff and you understand the last couple of days of lessons, you will be golden for the assignment on Thursday. Um, that'll go up on Thursday morning, and you'll have a chance to email that to me for grading. It'll be due on Thursday, later in the day. But yeah, good luck, chemists. If you have any questions on the understanding stuff here, please send me an email, and I can make videos or reply to you directly. Whatever works better. And yeah, this unit's a bit different because it's very conceptual compared to the story, which was more math-based. So thank you for watching these lessons and listening to them, since I think that'll help make it a bit more interactive. So yeah, I hope you all have a lovely day and take care.